Hello friends, welcome to my YouTube channel RJK Tutorials. So today I'm going to cover my presentation on a topic called as median. Now median is one of the measures of central tendency. As you know that there are three measures of central tendency. One is mean, median and mode. So today's presentation is covered on median. Now median is the central value of the variable that divides the series into two equal parts in such a way that half of the items lie above the value and remaining half lie below the value. So in other words, if you are dividing the series into two equal parts in such a way that one part is going to lie above the central value, the other part lying below the central value, that central value which is going to divide the series in two equal part, so that central value is called as the median. So median is defined as the value of the middle item or the mean of the values of the two middle items when the data are arranged in ascending order or descending order of the magnitude. So in case of median, if you want to calculate the median, so first of all you have to ensure that the data is arranged in either ascending or descending order. So only then you will be able to divide the series into two equal parts. Now, the calculation of median in a series of individual observation or the calculation median for ungrouped data. So there are different methods and formulas. So the median related formulas can be any of the following. So it can be related to the discrete series, or it can be related to continuous series, or unequal class intervals, or calculation median in the open end class intervals. So these are the various varieties of problems or different series of problems where you can get it actually. So in case of discrete series, you'll be having the x and f, that is you'll be having the x column as well as the frequency. In case of continuous series, you'll be having the class interval and the frequency. So in case of unequal class intervals, so the class interval will not be in a particular series, so you may have to add and subtract 0.5 to the upper and lower limit, so in order to make it as a continuous series. So let us see some of the problems and you will understand how to find out the median in the different varieties of problem. So in case of ungrouped data, so you can have a problem where you will be having only the x values. So in such cases, you have to find out whether it is an odd series or even series. So when you arrange the data in ascending or descending order of the magnitude, so the median will be the middlemost value in case of odd number. Odd number in the sense, if the count of the series, if the count of the numbers in the series is odd, the middlemost number will be the median. So in case of even, the median is the mean of two middle values, because in case of mean, what happens, there will be two numbers in the middle, so you have to take the average of two numbers in order to find out the median. So in case of odd series, the middlemost number is the median. In case of the even series, the middle two most number average you have to take in order to find out the median. Suppose if we have the following series, 15, 19, 21, 7, 10, 33, 25, 18 and 5. So first of all, you have to arrange these numbers in ascending order. So the ascending order will be like 5, 7, 10, 15, 18, 19, 21, 25 and 33. Now here if you look at the count, so count will be, it is 9 here. So the count is 9 here. So it is an odd series. So therefore, you have to use this formula. So what is the formula? N plus 1 divided by 2. So 9 plus 1 divided by 2 will be equal to 5. So therefore the fifth item in the arranged series 1, 2, 3, 4, 5, that will be 18. So 18 will be the median. So this is how you find out the median in the odd series. Now coming to the even series, let us take this particular problem. 15, 19, 21, 7, 10, 33, 25, 18, 5 and 23. Arranging this, you will be getting the numbers like this. Now here, how many numbers are there? So here you are having 10 numbers. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now here the middlemost number is not one number, two numbers are there. So what are those numbers? So that you have to find out. So by using the formula n plus 1 divided by 2. So 10 plus 1 divided by 2 is 5.5. So 5.5 basically means it is the average of the fifth and sixth number. So the fifth number will be 18, the sixth number will be 19. So average of these two number will be 18.5. So that is how we have to find out. So please remember, if it is even series, the average of the middle two numbers will be the median. In case of odd series, the middlemost number will be the median. So this is another problem where you can find out the median. The systolic blood pressure, which is measured in of mercury, of eight male patients are given below. Find out the value of the median. So here you can see here how many numbers are there. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 numbers are there. So first of all, you have to arrange this in ascending order or in the descending order. So here ascending order is been arranged, and here you can see the middlemost number is 120 and 130. So you don't have exact one number, you have two numbers here. So n plus 1 divided by 2. So if you are using this particular formula, then it will be, so here you have 10, so it will be 5.5. So 5.5 is fifth number, and the sixth number you have to take here. So the middlemost number will be here 120 plus 130 divided by 2. That will be 250 divided by 2, that is 125. So the middlemost number will be here 120 and 130. So this average you have to take here. I'm sorry, not 10 here, 8 values are there. So there are 8 values. So even number of these values will be middlemost number, that is fourth and fifth one. So therefore it will be 120 and 130. So the average of 120 and 130, it will be 250 divided by 2, that is 125. So 125 will be the middlemost number or the median. So in case of discrete series, as I told earlier, we'll be having two columns, X as well as the F. So X column is marks here, the F column is number of students here. So here there is no need to arrange because the X is already arranged here. You can see here it is arranged in ascending order 5, 15, 25, 35, 45, and 55. Now in case of for discrete series, you have to take the count of n as sum of the frequencies, which is equal to 180. So in discrete series, you want to find out the median, then you have to calculate the cumulative frequency. So cumulative frequency is the first frequency, you have to take the first and second frequency is the accumulated for second one. So like that you have to keep on adding. So one to another next frequency, if you keep on adding it, you will be getting the cumulative frequency. So the cumulative frequency will be 10, 30, 60, 110, 150 and 180. So NE is here 180. Now in order to find out, you have to use the formula, the same formula, n plus 1 divided by 2. So N is 100 here. So 100, I'm sorry, not 100, is 180. So N is 180 here. So 180 plus 1 divided by 2. So it will be 90.5 that item. So 90.5 that item. So same formula are using n plus 1 divided by 2. So 180 plus 1, that is 181 divided by 2, that is 90.5 item. So how to locate this particular number? You have to locate in the cumulative frequency. So the number what we are getting is 90.5. So 90.5 comes under in this particular cumulative frequency 110. So from 61 onwards. So 61, 62, 63 till 110 you will be getting in this particular number 110. So that corresponding X is 35. So therefore the median is 35. So this is how you have to locate. So first you have to take the cumulative value, find out the cumulative value and locate in the cumulative frequency column. The corresponding X will be the median. So here 90.5 comes in 110. So therefore corresponding frequency is 35. I'm sorry, 35 is the corresponding X value. So similarly, we take one more problem. Calculate the median for the following problem related to blood samples of 43 patients. So the number of patients are given here 6, 4, 16, 7, 8 and 2. The blood pressure is given 29, 25, 50, 40 and 80. So first of all, arrange the marks in ascending order and preparing the following table. So here the X has to be arranged in following order. So following order in the sense in the ascending order. So because here you can see the blood pressure is not arranged in a particular order. So here you have to arrange this in a particular order, either in ascending or descending order. So the ascending order will be 9, 20, 25, 40, 50, and 80. So corresponding frequencies you have to rearrange here: 4, 6, 16, 8, 7, and 2. So some of the frequencies will be 43. So you have to calculate the cumulative frequency. So here n is 43. So therefore the median is equal to n plus 1 divided by 2. That is 43 plus 1 divided by 2. That is 44. That comes to 22nd. So 22nd value will be located in this number 26. That is from 11 onwards till 26 will be there in this 26 value. So the corresponding x is 25. So therefore the median is 25 here. So in case of group data, we have this particular formula. So L plus of n by 2 minus PCF divided by f into I. So L is called as the lower limit of the median class. PCF is the previous cumulative frequency of the median class. F is the frequency of median class. I is the size of median class. And capital N represents the total number of observations or total number of frequencies. Now here you have a problem. So class interval is marks. The number of students is frequency. So class interval you have 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. So the frequencies are given as number of students, that is 10, 20, 30, 50, 40, and 30. So here you can see class interval is already arranged ascending order. So there is no need to arrange it. Now you have to calculate cumulative frequency. So the cumulative frequencies will be 10, 30, 60, 110, 150, and 180. So here you have n as 180. So how to calculate this one? So first of all, you have to take n and you have to divide by 2. So because as per the formula, n by 2 is 90. So 90 comes under 110. So that corresponding class interval is 30 to 40. So this is where you have to locate the median. So the lower limit of this 30 to 40 is 30. So L is 30. F is 50, PCF, that is previous cumulative frequency to the median class, is 60. So, and the cumulative frequency for the 30 to 40 is 110. So what are the numbers we require here? As for the formula, lower limit we require here, n by 2 we already calculated, minus PCF we calculated, divided by F you have to calculate, and I you have to calculate. So by putting these values, we'll be getting L as 30, F as 50, PCF as 60, and N we already know it is 180. So 180 divided by 2. So by putting this, we'll be getting like this. So 30 plus of 90 minus 60 divided by 50 into 10. So by simplifying this, we'll be getting median as 36. So this is how you have to calculate the median. So one more problem here. So it is a cumulative frequency you have to calculate because this is a continuous series. So you have class interval and frequency. Cumulative frequency will be 3, 8, 28, 38, and 43. So total will be 43 here. So n by 2 is 43 divided by 2 is 21.5 minus. So minus the previous cumulative. So when you are dividing 43 divided by 2 is 21.5. So 21.5 comes under 28. So the corresponding class interval will be 40 to 50. So here you have to locate. So 40 plus 21.5 minus the previous cumulative frequency is 8 divided by frequency of this median class interval is 20 into the size of the class interval. So size is, so what is the width of the class interval? That is 40 to 50 is 10. So that comes to 46.75 mg per dl. So that is what the value for this particular problem. So 46.5 is the median value. So in case of so there is one more problem here. So the data recorded on a production of tablets during 6 consecutive days is presented below. Calculate the median. Now here class interval is given 0 to 10, 10 to 30, 30 to 60, 60 to 80, 80 to 90, 90 to 100. Now here we have to put this particular data in this form. So cumulative class interval you are finding. I'm sorry, cumulative frequency you are finding, not the class interval. Cumulative frequency is 521, 51, 63, 69, and 70. So n is equal to 70 here. So once again, by using this formula, you'll be getting 30 plus of 14 divided by 30. So here the n will be 70. So 70 divided by 2 is 35th item. So the 35th item comes under the class interval 30 to 60. So here the lower limit will be 30, n by 2 will be the 35th item, CF is 21 and F is equal to 30. The width of the class interval is 30. So by putting all these values, we will be getting 44 as the median. So in case of there is one more problem here. So here we have a different type of problem here. The class interval is given less than 10, 10 to 20, 20 to 30, 30 to 40, 40 and above is the other class interval. So the frequency of 4, 8, 14, 6 and 4. So you have to take here, you have to calculate the cumulative frequency. So once again n by 2 we have to calculate. So n by 2 is coming to 18. So therefore you have to locate here. So 20 to 30 will be class interval. So therefore L is equal to 20. So n by 2 will be 18. PCF, that is previous cumulative frequency, will be 12 divided by 14 into 10. That comes to 24.29. So next one is the Ogive curves. So Ogive curves is a method of finding the median by using the curves. The curves are called as cumulative frequency curves. So cumulative frequency curves are called as the Ogive curves. Now this sort of graph includes plotting the class interval as versus the cumulative frequencies. So there are two types of cumulative frequencies. One is the less than cumulative frequency and more than cumulative frequency. So normally class interval is taken on the x-axis, cumulative frequencies are taken on the y-axis. So based on that, you will be plotting the graph. So since we have two datas in the cumulative, in the class interval. So one is the lower limit and the upper limit. So based on that, you have two types of cumulative uh, frequency curves. One is less than cumulative Ogive curve or cumulative frequency curve, or next one is more than cumulative frequency curve or more than Ogive curve. So in case of less than Ogive curve or less than cumulative frequency curve, so this is the steps to be followed. To present a less than Ogive graph, add the frequencies of all preceding class intervals to the frequency of the class. So this is what you have to do. The step number 2, after that, plot the less than cumulative frequencies on the y-axis and upper limit of the corresponding class interval on the x-axis. In step number 3, in the last step, join these points by smooth freehand curve, which is resulting less than Ogive. So less than Ogive curve is increasing curve and slopes towards or upwards from left to right. So this is a upward moving curve which moves from lower left hand side to the upper right hand side. So less than Ogive curve or less than cumulative frequency. So here the plot goes against like this. Less than cumulative frequencies have to be plotted on the y-axis against the upper limit of the class interval on the x-axis. So here we have the class interval. It's a problem. So here the draw a less than Ogive curve or less than cumulative frequency curve from the following distribution of marks of 50 students in the class. Class interval is 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80. The number of students are 6, 4, 15, 5, 8, 7 and 5. Now here we have to calculate cumulative frequencies. So it will be like 6, 10, 25, 30, 38, 45 and 50. Now as per this particular data, as I told earlier, so the upper limit of the class interval should be plotted against these cumulative frequencies. That's 20 against 6, 30 against 10, 40 against 25, 50 against 30, 60 against 38, 70 against 45 and 80 against 50. Now here the marks are taken, the class interval is taken on the x-axis and the number of students on the y-axis. So this is how you will be getting less than Ogive curve. So this curve is drawn by freehand movement. So more than cumulative frequency curve, more than Ogive. So here after the plot, the more than cumulative frequencies on y-axis should be taken, and uh, the upper limit of the corresponding class interval on the x-axis. So here this is how you have to plot the curve here. Now I think there is a mistake here. So after plotting more than cumulative frequency y-axis on the upper limit, corresponding lower limit of the class interval. It's not the upper limit. Lower limit of the class interval should be plotted against the x-axis. So in more than Ogive curve, you have to take the lower limit. In case of the less than cumulative frequency, you have to take the upper limit. So here you have to take the lower limit. So here the lower limit is more than 10, 20, 30, 40, 50, 60, 70. The cumulative frequencies are. So from top you have to subtract here. So what is the total frequencies of all the class interval? It is coming to 50. Then 50 minus um, so you have to you have to add the frequencies from below, like 5, 5 plus 7, 12, 5 plus 7 plus 8, 20, 5 plus 7 plus 8 plus 5 is 25, 5 plus 7 plus 8 plus 5 plus 15 is 40. Then you have 45, then you have 50. So from below you have to add the cumulative frequencies. Then here you will be getting a graph which is moves down from the upper left corner to the lower right corner. So when you're combining this both, this is how it goes on. So the upper limit against the increasing cumulative frequency, lower limit against the decreasing cumulative frequency. So when you combine these both, this is how you will be getting a graph. So less than Ogive curve and more than Ogive curve. So remember this one. So the upper limit against the increasing cumulative frequency, and lower limit against the decreasing cumulative frequency. Now it comes decreasing because from the bottom we are going to add the frequencies to the top. And this is how you get the less than and more than Ogive curve. Now, how do you find out the median here? So, finding the median, what you have to do is you have to take the n by 2 value. So, what is the n value here? So, that value you have to divide it by 2 here. Now, here we know that the total sum of the frequency is 50. So, the 50 has to be divided by 2 because we are finding the centralmost value. So, that value you have to locate here. So, how do you locate here? So, I'm going to explain here. Now n by 2, we know that n by 2, so that will be equal to 50 divided by it is 25. So that 25 you have to locate here. This is n by 2. From here, you have to draw a straight line. Usually that straight line will be meeting at the intersection point. So from this, you have to draw a perpendicular line to the x-axis. So this distance, what is that distance? From here to here, that distance from the origin to this perpendicular line where it is touching on the x-axis, this width you have to find out. So this width basically tells you the width of the median. So you have to measure it and you'll come to know the median value. So this is how you have to find out. So don't forget to divide n by 2, locate that in the y-axis, draw an horizontal line touching to the intersection point, and draw a perpendicular line to the x-axis. The width of the perpendicular line from the origin gives you the median value. So unlike the median, some of the characteristic features of median. So unlike the arithmetic mean, the median can be computed from open end distribution. This is because it is located in the median class interval, which would not be open end classes. And it is not influenced by extreme value. It is preferred in case of distribution having extreme values. That means in case of extreme values, arithmetic mean cannot be used. In such cases, median can be used actually. So whether it is open end or closed end, median is most appropriate measure of central tendency. In case of qualitative data, where items are not counted or measured but are scored or ranked, it is the most appropriate measure of central tendency. So merits of median, it is easily understood. It is not affected by extreme values. It can be located graphically. It is the best measure of qualitative data such as beauty, intelligence, honesty. It can be easily located even if the class interval is in the series are unequal. So that is one advantage. At the same time, it is also having certain demerits or disadvantages. It is not subject to algebraic treatment. That means further algebraic treatment cannot be used in certain cases. It cannot represent the irregular distribution series. It is a positional average and it is based on the middle term only. So if you are considering the other terms, then it cannot be used. It is an estimate in case of series containing even number of items and it does not have a sampling stability. So sampling stability it doesn't have, so therefore it cannot be used in case of sampling. So I hope that you have understood the concepts of median, how to calculate median in individual, discrete, and continuous series, and the Ogive curve. So thank you. Don't forget to subscribe my YouTube channel, Ajaki Tutorials. Thank you.